Pokemon FireRed and LeafGreen are finally here on the Switch, and it's time to explore Kanto like it's 2004 all over again. And while most people are going to be taking the nostalgic trip through the region, I thought it was the perfect time to bring back my old shiny bot for a new adventure. So here's how I made a shiny hunting machine that can automatically encounter, check, and flee from Pokemon until one of them looks a bit funky. Let's get right into it. Around this time last year, I made my classic shiny bot with an Arduino kit, some dodgy soldering, and a poor DS Lite that ran 24/7 to find me some shiny Torchics and a lot of shiny Poochyena. And then I stepped it up even further with my second version, or technically third, with custom PCBs, Xbox controller support, and a camera reading the entire screen to hunt for a whole bunch of shinies in both Gen 3 and 4. But the biggest downside to those systems was of course the fact that I had to butcher some original hardware in order to interact with it. But lucky for me, and my Switch, this version of the setup doesn't require any soldering, any dodgy wiring, or mods of any kind. It is all done through the wonders of Bluetooth. And it's rather easy to set up. Well, almost easy. This project uses 4 main components: a Nintendo Switch sat in its dock, an HDMI capture card, a PC, and a Raspberry Pi. You could probably shrink it down to just 3 components with a laptop running Ubuntu or a more powerful Pi that can read the capture card directly, but this way works just fine. But what is this system able to hunt? Well, pretty much everything if I get the sequences and code in place. The easiest things to hunt are static encounters with soft resets like the starter Pokemon or Snorlax for example, and also random encounters in tall grass, where the character just has to spin around on the spot. But by fleshing out my Python code a bit more, this system could hunt literally every single shiny Pokemon in the game. But what about those that say that this is cheating or modding, and I might as well generate the Pokemon instantly, because it's basically the same? Well, it's not that deep, and this is fun to do, so it's fine by me. So I have my Nintendo Switch with Pokemon LeafGreen, and that is sitting in its dock. The HDMI output goes into a cheap Ugreen capture card that is plugged into my PC. This video is picked up by OBS, and with a plugin for RTSP streaming, that is broadcast over my local network, and literally everything else is handled by the Raspberry Pi, which picks up this feed, analyzes it, and sends commands back to Nintendo Switch using NXBT over Bluetooth to emulate a controller. Now setting up the Switch, the PC, and the video stream was very simple, but the Pi, not so much. Like I said for this project, the main package I'm using to achieve this is called NXBT, a really cool program that allows you to spoof controllers for the Switch to create basic macros, send controls via a web app, or what I'm interested in, accessing the Python API to control everything. If you don't know much about Linux or Python or any of this stuff, I will say getting it to work may be a bit of a hassle if you wanted to try it yourself, but here's just a few issues I ran into. So on their site and GitHub repo, you can download the package through pip, which makes getting it rather easy. However, the last release for this project was in 2021, which meant that a lot of the dependencies that it was looking for are rather out of date, and newer versions may or may not support the same features. I had to go through a slog of either updating or downgrading packages until everything fell into place, but eventually I got it working after bashing my head on the keyboard enough. Another issue is that because it requires root access to use the Bluetooth, it has to be set up in a specific way, and I literally only use my Pi for dumb projects like this, so not exactly well versed in how to use the Linux command line. Again, it was just typing random commands until it worked. One issue that I had that I didn't really see mentioned anywhere was that when I would run a simple test program, the controller would never pair with the Switch, even though it said it was trying to, and I could not figure it out. Well, I just opened up another tab, looked at Bluetooth control, and saw that it was trying to pair and then would wait for authorization. So I would have to type yes into the command line to get it to pair. I spent ages thinking it wasn't working, trying other stuff, but that was literally it. There's probably an easy way to skip this step, but it takes me 2 seconds at the beginning of a hunt, so it's not worth fussing about. The biggest issue I faced was the fact that RTSP streaming, by nature, is rather delayed. There's a certain amount of latency that's basically impossible to remove because of how it works, and I was running into the challenge of having to add delays for the stream to catch up before the checks occur. At first I tried other solutions to this problem, like an SRT stream through OBS, or streaming the virtual camera over UDP to the Pi, but these were lossy, so it would be a lot quicker, but most of the frames were only partials, and the bottom half was just skipped entirely. which was obviously not ideal. I tried for ages setting up various types of streams with all sorts of things to try to beat the latency of an RTSP stream, but there was just no way to be faster without losing frames or running into issues. I even tried the simplest approach, plugging the capture card directly into the Pi. It detected it just fine and saw that it was a video device, but when I tried to read frames from it, it would just time out and never go anywhere. This wouldn't be an issue at all if you had a better Raspberry Pi, especially one that wasn't headless, or a more powerful device, or just a PC or laptop running Ubuntu that can just use OBS locally, but I didn't fancy wasting money on new stuff just to see if it works. I'd much rather get what I have working. So I stuck with the delay and I was trying to figure out how I could work around it, because it needs to check the screen after every step to see if an encounter starts. I initially tried adding a delay to the encounter check that was roughly the time it takes for the stream to catch up, but that would slow each check down by about 2 seconds. Now, 2 seconds isn't a lot of time, but when it could check for 10 encounters before actually hitting one, that's 20 seconds added. And then, if a hunt goes to odds, so 8,192 loops, that's 45 hours of time added to a single hunt, which is not exactly optimal. But then, after a few rounds of testing, which took hours off my life, I realized that it doesn't actually matter if the stream is delayed or not for checking an encounter. If it spams left, right, check over and over again, it can keep trying to move left and right even when an encounter starts. The game will just ignore that. The only thing that matters is the time between the start of the encounter and the shiny check, and those aren't affected by the stream delay because they're both reading the same stream. The only part that's slightly delayed in the whole process is when it hits A to skip the encounter text. The rest can just run on as if it's live. I wasted basically an entire day solving a problem that I then just ignored, but oh well. Now that I've got the controller hooked up and the stream running smoothly, let's get into the main loop of the program. And luckily for me, I literally wrote all of the code it needs a year ago. So I just had to tweak a couple of lines and it was all good to go. I copied over my sequences from the previous project and they work perfectly here. But how does it actually find a shiny? Did I make some intricate database that stores the color values of every single Pokemon and compare it to a pixel on screen? Now that's too much work and completely unnecessary. So here I am standing in Viridian Forest. If I start spinning about and find a Pokemon, the screen goes black. That's the first step the process is looking for to know when an encounter starts and to stop spamming the arrows. Then, it waits until the text box at the bottom pops up saying a wild Pokemon appeared. This is the key to hunting shinies, because when the shiny sparkle goes off, it delays that menu for a couple of seconds. So it takes a screenshot of the encounter, crops the area down to that text, and checks to see whether or not the text is there by using a very simple threshold algorithm that makes every pixel either black or white depending on how bright it is. And then it just counts the pixels to see if it was what it expected. As the text is white on a dark blue background, it's very easy to see whether or not it's popped up after the set time. If it's there and isn't shiny, for this runaway sequence, it then presses A to send out a Pokemon, waits until the menu pops up, presses down and right, and runs, ready to do it all over again. It works in exactly the same way as the old camera-based system, I just had to tweak some values. And because the capture card is showing a perfectly clean image at all times, it's not a janky camera, it works so much better. I can't accidentally knock it and have to reset the whole thing. Perfect. I left this running for hours on end, stepping in any time it skipped a button press due to a dodgy signal, or got stuck doing something it shouldn't, and for the most part it ran perfectly. And after 75 hours it managed to find its first shiny, this amazing golden Caterpie here. And because I had the idea of running a separate feed that stores the last 15 seconds, I have this clip to show it appearing, and as you can see, yeah, that didn't work. This disappointed me a bit. It's just some common Weedle, but with newfound technology, here's what this encounter could have looked like. Amazing. I have fixed the clipping since this, so don't worry there. And if you're wondering, the recording is running at a low frame rate at only 360p, but that's because the Pi can't really handle anything bigger. Like I said, if you're going to try this yourself, hopefully you've got a Raspberry Pi 4 or 5, something more powerful, or use an external Bluetooth adapter with a virtual machine running Linux that can just do everything with ease. My piddly little Pi 3B is trying his best though, and he got there in the end. And now that I've got my first shiny Pokemon, I can finally start actually playing the game. 75 hours in, and I'm going to make it out of Viridian Forest just how the game was intended. Overall, it took me 4 days to find a shiny Pokemon, which was longer than I had hoped because I needed the game and OBS to be free and also record footage for this video. But then, as I started to edit what I had together, literally 10 minutes later, a second shiny Caterpie appeared, which is just typical, but hey, now I have a cool Butterfree. If you're crazy enough to try this project out for yourself, I'll leave a link in the description for both my code and the NXBT GitHub page. However, it may be worth looking into some forks of the project that are much newer. I know a few exist, but I stuck to the original and managed to get it working. Let me know in the comments if you do try it and what methods you found worked best. I'm so glad they're finally bringing the old classics to the Switch, even if they are a bit overpriced, have no scaling options, and have a store listing for every single language. They're still great games, and I'm going to enjoy them once more. But anyway, thank you for watching. To round off this video, let's speed run through another edition of Subscriber Wars while I tell you about what's coming up next. I've been working on a project called IG for a couple of weeks. It's a simple incremental game where goblins collect resources in a forest. And it's been so fun to make, and I've got a devlog coming for it very soon. So soon in fact that it was supposed to be the next video I posted, until this project stepped in for a few days. I'll get that all finished up and out in a week or so make sure you subscribe so you don't miss it, and enter the arena to battle everyone else. Huge thanks to my members on both YouTube and Patreon for their support, it's massively appreciated. Go check out my Patreon for weekly updates and other random bits. Congratulations to Lembot7 for winning this round of Subscriber Wars, and I'll see you in the next one. Cheers.